Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In the previous sessions, we have seen about operating systems overview. Today we are going to see about process management. So let us see the overview of the presentation. So process management we are going to discuss. Next, process in memory, then attributes of a process, then process states, then process control block PCB. So let us see the process management. First, let us see the definition of process. So what is a process? A program under execution is known as process. So whenever we are doing the program which is under execution, means which is under compilation or ready for the execution, that is what a process. So next, what is process management? Process management can help organizations and they can improve their operational efficiency. So they can organize, the organizations can improve their operations effectively and it can reduces the costs. And next, increase the customer satisfaction. Whatever they are going to provide, they can increase their customer satisfaction and they maintain compliance with regularity requirements. So whatever the requirements given by the customer, they can be improved throughout the requirements. That is what how we are going to manage that products or manage that process according to their compliance with regularity requirements. It involves analyzing the performance of existing processes. So whatever we are going to analyze, that can improve its existing processes, so which are under existing. So already the process which is present, again if we want to exist, so whatever the process can be existing, that can be analyzed and the performance of the existing processes. And next, identifying bottlenecks. How we are going to identify their bottlenecks and making changes to optimize the process flow. So whenever you are going to optimize the process which is under flow, so you can change their optimize, means size can be changed or the flow of the process can be changed and we can easily identify the bottlenecks. This is what how we are going to manage the process. So let us see next, process in memory looks like. How the memory look like? It looks like first stack, then heap, then data and text. So how the process of a memory looks like means it is like stack, heap, data and text. So stack is nothing but the variables which are arranged or which are organized in LECO order. So variables in LECO order. LECO is what? Last in first out. The variables which are arranged in last in first out is known as stack. Next, what is heap? Heap is nothing but it is dynamically allocated memory. So how the memory is allocated? It is allocated dynamically. So dynamically allocated the memory. That is what? Heap. Next, what is data? Data is nothing but global variables. All the global variables are nothing but data. Next, what is text? Text is nothing but converting the code or writing the code. Converting the program code or text code. That is what? Text. So this is what how the process looks like. Memory, stack, heap, data and text. So next, what are the attributes of a process? The attributes of a process are the following. So first one is process ID. What is process ID? For every process they will be having some unique ID. That is what? A unique identifier assigned by the operating system. So for every process there is an identifier to assign the process. So for that we are having some unique IDs for each process. Next, process states. Process states can be ready, running and still waiting, terminated and exit. So that are some process states. Next, what are CPU registers? CPU registers are nothing but it is like a program counter and CPU registers must be saved and restored. So how the registers are saved? Program counter is nothing but the execution of the next instruction is known as program counter. So in the CPU registers must be saved and they can be restored with a process when a process is fabbed in and out of the CPU. So the process can be in or maybe out, that is from CPU. Next, how the accounts information can be stored. So, amount of CPU used for process execution have some time limits. So, for each the executions will be having some time limits and they will be have some execution ID. That is what about accounts information. Next, what is the input-output status information? In this example, devices allocated to the processes and open files. How the open files, when the input-output, so when I am taking input, I say I am typing some document. So what is the output here? I want the printout of the document. That is what input-output status which we are want from the input-output. That is what input-output status information. Next, CPU scheduling information. In this example, priority, different processes may have different priorities. So, for each process, it consists of different priorities. Based on that priorities, we are going to schedule our algorithms. That is what about CPU scheduling algorithms. For example, a shorter process assigned as high priority. So, for this, a short process 0 is assigned as high priority in the shortest job first scheduling algorithm. So, in this we are going to see about SJF algorithm in the CPU scheduling algorithms in detail. Next, what are the different process states we are going to see? So, process states. A process is one of the following states. So, a process consists of one of the following states. What are they? New, ready, run, wait and complete. Complete is nothing but terminated. So, new is what? Newly created process or being created process. So, a process is created, that is what? Under new state. Creating of process. Let us take P1. P1 is creating one process. So, next, ready. Ready means what? After the creation, we are going to move it for the ready state. After creation of P1, we are sending for the ready state. So, ready state, what that is do? The process is ready for its execution. So, getting ready for the execution. Now, P1 is under ready state for the execution. Next, what is the run state do? Currently running process in CPU. Only one process at a time. So, P1 is under execution. No other P2 can't enter unless P1 completes its execution. That is what about run state. So, only one process at a time can be under execution in a single processor. So, what only P1 completion or after completion of P1 only P2 can enter. Otherwise, without completing P1, P2 cannot enter. That is what about run state. So, wait or block. When the process requests input-output access. So, when the process is under requesting, that is what waiting for the CPU. That is what waiting access block or waiting for state, waiting state. Next, complete or terminate. In this, the process can be completed its execution and they will get exit. That is what about complete or terminate state. So, let us see the diagram for process states. So, see here, first, the process new starts its creation. So, P1 is created. So, getting into ready state. So, P1 is entering into ready state. When the P1 is getting ready, so it starts the scheduler dispatches P1 to the running state. So, now it is under running state. If no any error occurs in the running state, it gets terminated. So, output is printed here. If any interrupt, if any error occurs, it again goes for the ready state and starts its execution. So, again gets ready, again goes to running and again gets terminated. Next, so when the process P2 is under waiting, it will go after completion of P1, P2 is under waiting. So, P2 starts, again go to ready and then again go to running and next go for terminate. That is what when the second process is under waiting. This is what about process states. Next, PCB, nothing but process control block. As the operating system supports multiple programming, so it supports multiple programming. It needs to keep track of all the processes. So, doing the multiple programs at a time can't be possible. So, giving some tracks for each processes, that is what task control block, or we can say it as process control block. So, for this task, the process control block is used to track the process execution status. So, for each track, it consists of some processes execution status. Each block of memory contains information about the. So each blocks contains some information about the process. So first one is process state, next program counter, and next start pointer, and next status of opened files and scheduling algorithms, etc. So let us see about first pointer. Pointer is nothing but it addresses the next variable. It addresses the next variable. That is what pointer. Next, process states are nothing but just now we discussed about new, ready, running, waiting, and terminated. That is what about process states. Next, what is process number? Process number is nothing but having some process IDs. Next, program counter, it is nothing but it executes the next instruction. Next instruction. That is what? Program counter. It executes the next instruction. Next, registers are nothing but stores the informations. Stores the data. Next, memory limits are nothing but it consists of RAM, ROM, and how much the data can be stored up to the limit. That is what? Memory limit. Next, open file, list of open files. When they are under open files, nothing but input output files are opening. That is what about list of open files. Next, miscellaneous accounting status data. So whatever the miscellaneous accounting, the data can be stored with their status information. So with the status information, how the accounts are stored. That is what? Miscellaneous accounting and status information. This is what about process control block PCB. Next, so today in this session what we have discussed, process control block and process states, and next process management, etc. So in this session we have discussed about process control block, process states, process management. So next in the next session we are going to see about CPU scheduling algorithms. So if you have any doubts, you can comment in the comment box. Thank you.